Welcome to the DIY Honda Garage channel. The DTC P0101 code signifies a problem with the mass airflow MAF sensor circuit, indicating either an issue with the sensor's performance or its range. The MAF sensor is critical for measuring the amount of air entering the engine, as it helps determine the optimal fuel-air mixture for combustion. On the Honda Civic 2011 to 2015, the MAF sensor is typically located between the air cleaner and the intake manifold. When this code is triggered, it may affect engine performance, fuel efficiency, and emissions. It's essential to follow a detailed troubleshooting process to identify and rectify the underlying cause of this error code. A thorough understanding of the components involved and appropriate checks is paramount to restoring the vehicle's optimal operating condition. The DTC P0101 error indicates a MAF sensor circuit range or performance problem. The MAF sensor measures the volume of air entering the engine and provides this information to the Engine Control Module, ECM. If the sensor is malfunctioning, it can send incorrect signals, leading to improper fuel management and poor engine performance. The sensor is often found between the air cleaner and the intake manifold, where it connects to various parts, including the intake air duct, PCV hose, and purge line. These components must be in good condition for the sensor to operate correctly. A poor connection or damage to any of these parts may directly affect the MAF sensor's performance. Diagnosing and resolving issues with these components is crucial before moving on to more complex diagnostics. Several possible causes can trigger the DTC P0101 error code. Firstly, poor connections or damage to components like the PCV hose, intake air duct, or air cleaner can lead to improper MAF sensor readings. These components need to be visually inspected to ensure no cracks or loose fittings exist. Secondly, a dirty or damaged air cleaner can restrict airflow, affecting the MAF sensor's ability to measure accurately. Regular maintenance of the air cleaner is essential to prevent such issues. Lastly, a faulty MAF sensor or intake air temperature IAT sensor can also be the culprit. If visual inspections do not reveal any issues, testing these sensors may be necessary. Thus, understanding these potential causes is critical for accurate troubleshooting. The DTC P0101 code may present several symptoms that indicate underlying issues. One common symptom is poor engine performance. The vehicle may hesitate or stall due to incorrect air-fuel mixture adjustments. Another symptom typically associated with this error code is decreased fuel efficiency, as the engine struggles to maintain optimal combustion levels. The check engine light will likely be illuminated on the dashboard, alerting the driver of an issue with the engine management system. Observing these symptoms should prompt immediate diagnosis and repair to prevent further complications and maintain vehicle reliability. It's essential to address these concerns promptly to ensure both safety and performance. The first step in troubleshooting the DTC P0101 code is to conduct a thorough parts condition check. Begin by inspecting for any poor connections or damage to key components, including the PCV hose, intake air duct, air cleaner, and purge line. A visual inspection will help identify any apparent physical damage, such as cracks or loose fittings. If these components appear to be in good condition, you may proceed to the next step. However, if any issues are found, it is essential to repair or replace the damaged parts before moving forward. This foundational check is necessary as it ensures that the components essential for MAF sensor operation are functioning correctly. The second troubleshooting step involves a visual check of the intake air duct. This duct plays an essential role in directing airflow from the air cleaner to the engine. Inspect it carefully for any signs of damage, such as cracks or significant wear, as well as looseness that could lead to leaks. Leaks in the air duct can significantly impact the accuracy of the MAF sensor readings. If the duct is found to be in good condition, you can progress to the next diagnostic step. Otherwise, any damage should be addressed by reconnecting properly or replacing the duct if necessary, ensuring that air can flow freely to the engine. During the third troubleshooting step, it is crucial to check the air cleaner element for cleanliness. A dirty air cleaner can obstruct airflow, leading to inaccurate readings from the MAF sensor. If the air cleaner element appears dirty, replacing it is necessary as it ensures optimal airflow to the engine, which is vital for performance. A clean air cleaner allows the MAF sensor to work correctly by measuring the right amount of air entering the engine. If the air cleaner is clean, you can then move on to the next step in the diagnostic process. Failure to check and replace a dirty air cleaner can result in persistent issues and diminished engine performance. The fourth step of troubleshooting involves checking the MAF sensor signal without running the engine. Begin by turning the ignition switch to the lock position and then back to the on position, ensuring all electronic systems are activated. Utilizing the Honda Diagnostic System, HDS, you need to inspect the MAF sensor readings in the data list. Ideally, you are looking for readings around 0.2 grams per second, GS, or about 0.5 volts. If the readings do not fall within this range, it indicates a potential problem with the MAF or IAT sensors. Should the readings be acceptable, you can then transition to the next step to further diagnose the situation and ensure complete vehicle functionality. Step 5 focuses on checking the MAF sensor signal while the engine is running. Start the engine and maintain the engine speed between 2,000 RPM and 3,000 RPM. During this phase, continue to monitor the MAF sensor readings using the HDS. An essential criterion here is that the readings should change in response to varying engine speeds. This change in data indicates that the MAF sensor is functioning appropriately. If the readings remain static, despite throttle changes, it suggests an issue with the MAF or IAT sensor, prompting you to take necessary actions. This diagnosis is crucial as it directly assesses the sensor's responsiveness, which is vital for accurate air-fuel mixture management. The sixth step involves a practical check of the MAF sensor's performance. Start by maintaining the engine speed at 3,000 RPM without load, meaning that the vehicle should be in neutral to avoid any resistance. After a short duration, monitor the engine control module, ECM, and check for the activation of the radiator fan, which indicates the sensor is functioning as expected. Following this, test drive the vehicle while recording key parameters such as engine speed and vehicle speed, along with readings from the MAF and throttle position (TP) sensors. After the test drive, observe the OBD status for DTC P0101 using the HDS. If the code indicates a failed status, replacing the MAF or IAT sensor becomes necessary. If passed, you may have an intermittent failure, suggesting that more detailed checks of connections and terminals are warranted. Final repair verification is a crucial part of resolving the DTC P0101 code. Begin by turning the ignition switch to the on position and resetting the engine control module, ECM, using the HDS. This process clears any previously stored codes and allows the ECM to reset its parameters. Follow that with conducting the ECM idle learn procedure, which helps the ECM adapt to engine parameters after repairs have been made. Finally, a test drive in conditions that reflect the previously recorded freeze data parameters is vital. Climbing through the engine speed and monitoring the vehicle speed, map sensor, and TP sensor readings, while observing the OBD status for DTC P0101 will determine if the problem has truly been resolved. This last step not only verifies the successful repair, but also confirms that the vehicle is functioning optimally. Preventive maintenance is key to avoiding issues associated with the DTC P0101 error code. One fundamental step is to regularly inspect the air cleaner and replace it as needed to ensure unrestricted airflow into the engine. A clean air cleaner can prevent strain on the MAF sensor and avoid unnecessary errors. Checking hoses and connections frequently can help identify any developing wear and tear before they lead to performance problems. Moreover, consider servicing the MAF sensor on an annual basis, which may include cleaning or replacing it to maintain its accuracy and functionality. Implementing these preventive measures not only contributes to the vehicle's longevity, but also assists in maintaining optimal performance while ensuring that emissions remain within regulatory limits. In conclusion, troubleshooting the DTC P0101 error involves a systematic approach to identifying and resolving issues with the MAF sensor circuit. Following the detailed steps, starting with visual inspections and progressing to more complex diagnostics, ensures thorough investigation and correction of the underlying problem. Maintaining the components related to the MAF sensor is crucial for ensuring long-term vehicle performance and efficiency. Regular inspections and preventive maintenance can help preempt potential issues before they manifest into significant failures. By adhering to this guide, Honda Civic owners can uphold their vehicle's reliability and operational excellence while ensuring compliance with environmental standards. Please like and subscribe to the channel. See you next time.